Hello friends, this video on Quadrilaterals part 14 is brought to you by examfear.com. No more fear from exam. Now let's take some numericals on the midpoint theorem. It's pretty interesting question. Triangle ABC, DEF are respectively the midpoints of AB, BC and CA. We have to prove that this triangle is divided into four congruent triangles by these points. See, D and E are midpoints. So I can say that DF is parallel to BC. So DF is parallel to BC. Okay, or I can say that DF is parallel to BE also. Correct? And DF is equal to B. Why? Because DF is, if you see by the midpoint theorem, DF is equal to BC by 2, and BC by 2 is nothing but BE. Correct? Now we have DF is parallel to BE, DF is parallel to BE, and DF is equal to BE. What does it imply? It implies DFEB is parallelogram. Now if DFEB is a parallelogram, D is a diagonal. If D is a diagonal, then this triangle and this triangle are congruent. Correct? Because a diagonal will bisect the parallelogram into two congruent triangles. That is what we have seen. So therefore I can say that this triangle 1 is congruent to triangle 2. Correct? Similarly, I can prove that this is a parallelogram. How? DF is equal to BC by 2, that is nothing but DF is equal to EC, and DF is parallel to EC. Therefore DFC is a parallelogram, and thus EF is a diagonal, so diagonal will bisect this parallelogram into two equal parts. So triangle 2 and triangle 3 will be congruent. Similarly, here if you see, DE will be parallel to AC because D and E are midpoints. Now D is equal to AC by 2, that is nothing but AF. So DEFA will be a parallelogram, and DF is what? Diagonal. So this will bisect into two congruent triangles, that is angle 2 and triangle 4. So triangle 1 is congruent to triangle 2. So triangle 2 is congruent to triangle 3, we have just seen, and triangle 2 is also congruent to triangle 4. So with this I can say that all the four triangles are congruent. Okay. Pretty easy question. L, M, N are three parallel lines intersected by traversal P and Q such that L, M, N cut off equal intercepts AB and BC, that is AB is equal to BC. On P, we have to show that L, M, N cut off equal intercept, that is DE is equal to EF. So given L parallel to M parallel to N, AB is equal to BC, to prove D is equal to EF. So for this, typically you have to join this, and it is already joined for us. If it's not joined, you have to join this. Now if you see in triangle ACF, you see this triangle, ACF, right? B and G are, you see in this triangle, B is the midpoint and BC is parallel to CF. What does it mean? That means C is the midpoint of AF. Converse of midpoint theorem. That is, AC will be equal to FC. Correct? So I can say that in triangle ACF, AB is equal to BC and BG is parallel to CF. Therefore, AG is equal to GF. Midpoint converse. Now AG is equal to GF is proved. Now let's take this triangle. We have A, D, F. Now if you take this triangle in triangle FAD, okay, G is the midpoint of side AF, that is AG is equal to GF, and G is parallel to AD. Correct? Because these three lines are parallel, L, M, N. Therefore, E is the midpoint of FD, that is FE will be equal to ED. And that is what we have to prove. P is equal to, correct, both are same. D is ED and FE is EF, both are same. Okay. So ABCD is a quadrilateral PQRS at the midpoints of these sides AB, BC, CD and DA. AC is the diagonal. We have to prove that SR is parallel to AC. That's pretty easy to prove because if you see this triangle DAC, with this triangle, S and R are the midpoints of AD and DC. Therefore, SR will be parallel to AC and SR will be half of AC. That is the midpoint theorem. Midpoint theorem. And that is what we have to prove. Next is we have to prove PQ is equal to SR. To do this, let's take this triangle. In triangle ABC, I can say that P and Q are midpoint of AB and BC. Therefore, PQ is equal to half of AC and PQ is also parallel to AC. Now, if you see SR and PQ both are equal to half of AC, correct? So, SR is equal to PQ is equal to half of AC, and that is what we have to prove. SR is equal to PQ. Done. Second is PQRS is a parallelogram. So, if you see, we have seen that for PQRS to be a parallelogram, we have seen that PQ is equal to SR, that is we have proved. If we can prove PQ is parallel to SR, we are done. So we have seen that PQ is parallel to AC and AC is parallel to SR. PQ is parallel to AC, AC is parallel to SR. Thus implies PQ is parallel to SR. So if PQ is parallel to SR and PQ is equal to SR, therefore using these two conditions I can say that PQRS is a parallelogram. Okay. ABCD is a rhombus. Let's create this rhombus. PQRS at the midpoints of side AB, BC, R and S. Right? PQRS at the midpoints of side AB, BC and CD. We have to prove that PQRS is a rectangle. Okay. And let's draw this diagonal. We'll leave this diagonal. Straight, yeah. See, we have proved that PQRS is parallelogram. Just now we have proved that. ABC is a rhombus. That means it is a parallelogram also. So PQRS is a parallelogram. We just proved it. Okay. So now we have to prove that PQRS is a rectangle. That means one of the angle is 90 degree. That is what we have to prove. Okay. Now if you see in this case, AB is equal to BC. Since it is a rhombus, AB is equal to BC. Correct? So what is AB by 2? That will be BC by 2. And what is AB by 2? Nothing but PB. And BC by 2 is BQ. So if PB is equal to BQ, these two angles will be equal. See, we have to prove that this angle is 90 degrees. So to prove this, if we can prove that these two angles are equal, then also we can prove it is 90 degree. Right? It is a parallelogram. If we can prove that these two angles are equal, we can prove this to be 90 degree. These two angles are equal, we know. So if we can somehow prove these two angles are equal, we can prove that these two angles are also equal. Correct? Let me name this. This will be 1, this will be 2, this will be 3 and this will be 4. Okay. So we know that if PB is equal to QC, angle 1 is equal to angle 2. That is equation number 1. So we have to prove angle 3 is equal to angle 4. How can we prove? So if we can take these two triangles and if we can prove they are congruent, then we can say angle 3 is equal to angle 4. Correct? This is SAP and I have to prove P is equal to Q. So, and A is equal to C R. Yeah. So if you see, AS will be equal to what? RC, half of the rhombus side. AP is equal to CQ, yes, half of the rhombus side. And SP and QR, SP and QR will also be equal opposite sides of the parallelogram, right? So triangle SAP is congruent to triangle RCQ. Therefore, angle 3 is equal to angle 4. Second equation. Now if you see, if you write an equation of these lines, right, these two triangles, that is, let me call this angle 5 and angle 6, right? Angle 1 plus angle 5 plus angle 3 is what? 180 degree. Similarly, angle 2 plus angle 6 plus angle 4 is what? 180 degree. So we subtract these two. Angle 3 is equal to angle 4, you can subtract. Angle 1 is equal to angle 2, you can subtract. So we can say angle 5 minus angle 6 is equal to 0, or angle 5 is equal to angle 6. So with this we have proved angle 5 is equal to angle 6. But we know that angle 5 plus angle 6 is what? 180 degree. Right? Because it's a parallelogram. And therefore, angle 5 is what? 90 degree. Angle 5 plus 5 is 180 degree. So angle 5 is 90 degree. Angle 5 is 90 degree. That means it is a rectangle. So we have proved that PQRS is a rectangle. So we have already proved that PQRS is a parallelogram in the past example. Now we have proved that one of the angle is 90 degree. That is PQRS is a rectangle. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.